Hey, batteries.
Uh-huh.
Yeah, what are batteries? Hey, basically a battery is very simple. A battery is just a galvanic cell hooked up in series.
Yeah. I
So
mean, you can just have one galvanic cell,
yes,
and that makes a battery.
many,
But
yeah.
yeah, I mean, as we've seen, most of these you get a voltage of around 1 or maybe 2 if you're really lucky. But how do you make a 9-volt battery? Well, you just take a bunch of 1.5 volters and you stick them together,
That's exactly right.
hook them together.
All right, and this is a picture right here of a lead acid battery.
Yep,
this is
it's
the
in your
kind that's found
car.
in your car. And if you look at this picture, you've got the cathode here. The cathode is made of PbO2. You can see that the reaction down there. And then the solution, basically the salt bridge, they're all actually immersed together. And so instead of separating them in separate cells
Yep.
like we have before, you actually have separated them by the pieces of metal.
Right, and this is exactly what we did with the cups of soda and the clock that we hooked up. We had the cells all submerged in one solution, and then we just stuck 2 of them together.
Because if I'm not mistaken, a car battery is 12 volts.
Yep.
Something like that.
Mm-hmm.
And you can't make 12 volts with those reactions on that table. And so they just put lots of them together, and they all add up to a total of 12 volts.
Yeah.
Now, if you were to take this is just an alkaline battery right here.
Yeah, this is how your little AA's, AAA's that you have in all of your portable devices,
Something
calculators.
that's intriguing
and
about
stuff.
this is if you look right here, is that essentially you've got the red is the anode, just a piece of graphite rod.
Yep.
And then they seal it with something, insulator. And then they have a paste. Now, we've been doing solutions. When you did the example in the podcast a little bit earlier, you had, they were aqueous solutions.
Yeah.
But paste is sort of an aqueous solution.
and
it's just thicker.
It's basically your salt bridge, isn't
Yeah,
it? Your
it is.
electrolyte paste. It's kind of like the porous cup.
Yep, and the outside is a zinc container, and guess what? You've made a battery. So
Ta-da.
so you've separated them in a little battery, and then of course the electricity can go out this way or and in this way. I can't remember which direction it flows, but yeah, physics people know that. Now another thing that's intriguing that we can talk about. Another thing that we can talk about is corrosion. And so I have here a picture of, or not a picture, an actual piece of metal. And you're seeing the picture. And what we've got here is just an old piece of corroded metal. And it's it's rusted. And so how does rusting occur? It's actually an oxidation reduction reaction that we can talk about. So let's take a look at the picture in the screen, and that will help us figure this thing all out. So what we've got here is this is how this particular piece of metal got rusted. So this is like a piece of metal right here, and usually it happens with some water. And what happens is that you get a water droplet, which creates a aqueous solution.
Mm-hmm. And in that water, there's generally some oxygen dissolved.
Yes, or something's dissolved in the water.
Mm-hmm.
This actually has to be some kind of salt of some variety. So if there's any kind of a salt that works, that's why salt water causes the corrosion to work so much faster. And so what happens is you create this water, and you actually create a couple of cells. And at the anode reaction, you get the iron turning to iron 2. And if there's oxygen present, which of course in the world, on the Earth, there's plenty of oxygen, you get this reaction. So you get these 2 half reactions to go in, and it works.
Yeah.
So that's how corrosion works.
This is my favorite.
Yeah, this is actually a pretty cool discussion. Another thing that you can have is you got a buried pipe, as in pictured in this picture.
Pictured in this picture.
Yeah, is a iron pipe. It's going to corrode because the water's moist, or the ground's probably moist from rain
and
and
that tends
this
to
and
cause
that.
problems. You have like water mains break and things like that.
Yeah, that happened recently
It
here.
did.
Yes, and people canceled school.
Yeah, although it wasn't a metal pipe, I think it was probably PVC. But
yeah.
anyhow.
Oh well. But if it was a metal pipe, it would corrode, and eventually it would just go away. In fact, I've heard that some cities like Chicago and New York, they've got all these ancient pipes which were metal, and they're now corroding, and they got problems.
Yep, and they do
like
this with boats.
hundreds of feet under the ground.
They do this with boats in the ocean too.
Yeah, let's talk about that in a minute.
Yeah.
All right. So how do you make sure this doesn't corrode?
Well, you turn it into a cathode.
So if you can make this the cathode, what happens is they took an anode, they add a piece of a more active metal, and magnesium is the classic one that they use.
Yes, it's called a sacrificial anode because we're sacrificing it. Okay, you just have to make sure you replace them often enough.
Yeah, let me tell you a story. My father used to own a boat, 50-foot boat, or yacht, I guess. He lived on it. Did I have a picture of that? No, I didn't. In his boat, of course, was a big boat. Okay, it had a propeller.
I guess that's a boat. Oh, there's the propeller. Okay, now it's
all right. It had a propeller, and he bought the boat. And before he bought the boat, he checked the boat out to make sure that it was in good shape and this and that. The one thing he didn't do, because it was expensive, which cost him more money, as you'll see, is that this particular propeller was starting to corrode. It was in the ocean, and that was a problem. because what they do is they take and they add actually a big piece of magnesium for the sacrificial anode. And guess what? The magnesium had already been destroyed, or had been used up, so to speak. Because as time goes on, the magnesium gets smaller and smaller and smaller.
Yeah, that's one thing we haven't really talked about is the anode actually,
Yeah.
it goes from a solid to an ion because that's the oxidation. Oxidation takes place at the anode. So you notice the solid magnesium becomes an ion, so eventually it'll corrode away. But on the cathode, the metal is actually deposited to the cathode. So it's going from an ion to a metal.
Yeah. And so the magnesium gets used up. And it was all used up, and so basically, I think it was like $4,000 or $5,000 to replace the propeller, because it was like 50-foot boat propeller, and they had to like lift up the boat onto 50-foot boats. Lifting them up on the dock is not cheap.
No.
And so and they put a new, and I guess these items right here, $20.
$20 and some guy with a scuba suit to hook it up, right?
I think so. Actually, I think you just it's not hard. I mean, so it might have cost him $100 to do it, or versus like $4,000.
I believe that's called a stupid tax.
Yeah, that was yeah. So he made a mistake. So now, folks, all right, I think we're done. And Mr. Sams, you are still drinking that nasty soda.
I am. I've been picking away at it. It's
I've
almost
still
lunchtime.
got a little bit of my vitamin water, and I think I'm going to take a swig of it.
All right, swig away. I'll take my
I
high
think we're
fructose
done.
corn syrup because
Oh!
caffeine.
Yuck!
I like caffeine.